Hi Doctor, my name is Mong Jun Kang, can call me CK. My registration number is AE180110. I'm from Group 1, Section 7. Today, I will represent my group to do the presentation for Experiment 5, ILC series and ILC parallel circuit. Before I start my presentation, I would like to introduce my group member. The first one group member is Wang Weiqi, and the second is Lim Wei Hang, and the last one is me. And now, I will do the presentation for simulation. Now I will do the presentation for activity 1, which is steady state behavior of ILC series circuit. First, we construct the circuit diagram according to a data sheet given. First, we construct a AC power supply, and then we parallel it with a AC voltmeter, and we continue connect to a AC ammeter, which is series to the AC power supply. After that, we connect to a voltmeter, and we connect to a resistor which is 100 ohm, and we parallel it with a voltmeter, and we continue connect to a inductor which is 50 millihertz, and we parallel it with a voltmeter, and the last we connect to a capacitor which is 16 microfarad, and we also parallel it with a voltmeter, and at the end we connect it back to the AC power supply, and we setting the AC power supply according to the left sheet given, which is the table 1, and we setting it to 10, and we need to multiply the square root 2, which is 1.414213562, and we set the frequency to the 50. Okay, wait for a while. I do the setting first. Okay, after that we press OK, and we start to simulate it. And since simulate, we need to take some time, and we need to wait until all the meter to get the stable data. And before all the meter before all the meter, we need to put the IMS, because in the table the left sheet given need the IMS, all the reading in IMS, so that we record it down, and then we repeat again the step, which is we change the voltage supply. We just change it to from the 10 to 20. We need wait for a while since the software a little bit hang. Okay, we change to 20, and same, we need to multiply the square root 2, and the frequency remain the same now with no change, and we start to simulate it. And also same like the before, we need to wait some time, and until all the meter get the stable data, and we record it down into the table given in the left sheet, and we just repeat changing the voltage according to the left sheet given until the 100. And that's all for the activity 1 part 1. And now I will do the presentation for activity 1 part 2. And the circuit diagram at the part 2 is same with the circuit diagram at part 1, and we just change the resistor from 100 to 50 ohm, and then we just repeat the step at the activity 1, which is we setting the AC voltage source to 10 and multiply the square root 2, and we set the frequency also the same with the part 1, and we start to simulate it. And we also take some time to wait the meter get the stable data, and we record down to the table given in the left sheet, and we just repeat the same step, which is changing the AC voltage to the left sheet given table which is 20, 30 and until the 100, and we record down the data. And this is the all activity 1. Now I will do the presentation for activity 2, steady state behavior of RLC parallel circuit. First, we construct the circuit diagram according to a lead sheet given. And first, we construct a AC power supply, and then we parallel it with a AC voltmeter, and we connect to a AC ammeter which is series to the AC power supply. And after that, we connect to a voltmeter, and then we connect to a resistor which is 100 ohm, and we parallel the resistor with a inductor which is 50 millihertz, and we also parallel it again to a capacitor which is 28 microfarad. And at the capacitor we need to add a resistor to let the capacitor can be run. And after that we connect back to the AC circuit. And before each element which is resistor, inductor and capacitor, we connect to a voltmeter. We need to measure the voltage of each element, and we setting the AC power supply to 10, and we need to multiply square root 2, which is this number, and then we set the frequency to 50. And before all the meter, we need to put a RMS to get the RMS value lah. And we start to simulate it, and we need to wait some time until all the meter get the stable data, and we record it down into the table. And after that, we just change the AC voltage Vs to the table given in the left sheet. We just repeat the step and record the data. And that's all for the activity 2. That's all my presentation for simulation. Thank you and stay safe.